in this segment, I want to spend a little bit of time talking about the chemical composition of bone. Now, bone is made up of two major types of chemicals, inorganic and organic. And remember that when we say inorganic, we're saying non-carbon containing, and organic, we're saying carbon containing. All right. Now, the inorganic aspect of bone is, primarily minerals and different combinations of minerals. All right. And up here on the board, I have the most abundant type of minerals you find. Now, you find a lot of calcium phosphate within bone, and also calcium hydroxide within bone. And basically once you start mixing these two together within the bone tissue, you form the most abundant inorganic molecule within bone called hydroxyapatite. Okay, and hydroxyapatite basically is found as crystals within the matrix of the bony tissue. Now remember that when we use the word matrix, what we're talking about, so let's say here's an environment, you've got a bunch of cells, okay, so here's some cells in here, and then when we say matrix, matrix is basically the water and all the different proteins and all the water and the proteins around here. Okay, some other books may say that the matrix is the tissue fluid, proteins, and any other inorganic or other materials found within here. Okay, but basically, so realistically, I guess for the sake of my class, think of the think of the matrix as basically the environment around the cells. Okay, the combination of the water and the substances you find, within the water of that cellular environment. Okay, and matrix is more specific to connective tissues. All right, and remember that's how we identify connective tissues, by looking at what cells do you find within connective tissues and what proteins do you find within the extracellular matrix. And this is what makes bone unique, is that there's not only a bunch of protein within the extracellular matrix, there's a lot of mineral within that area as well. All right. So basically, when you break it down, the most abundant protein you find within the cellular matrix is collagen. Okay. Collagen is the most abundant protein in all vertebrates, in most animals on the planet. All right. So, and of all the proteins in bone, collagen makes up about 80 to 90% of all the protein within bone. The remaining 10% of proteins that you find are really just not well understood in terms of their chemical composition and functions. All right, so we'll put our focus on collagen. All right, so basically you've got all these collagen fibers, all right, sitting in the extracellular matrix. All right, and then what you have is you have this hydroxyapatite. You've got these calcium salts all over the place. All right. And how exactly these calcium salts are shaped, how exactly they're oriented within the extracellular matrix is still debated to this day and not entirely well understood. But if you take a look at the characteristics of each of the collagen and the hydroxyapatite and how they have different characteristics, but yet how they both play into the role of bone, that's more important. All right. So basically, if we talk about hydroxyapatite, this is a mineral. It's a very, very solid, tough mineral that's very good at resisting compressive type forces, but is not the best at resisting any kind of forces where you need flexibility, like twisting or stretching. All right. So these give bone these calcium salts give bone very, very solid, tough characteristics. But if you put too much pressure on them, they can potentially shatter. All right, and that's where collagen comes in. This is where the flexibility of bone comes in. So you have the water in the extracellular matrix and all these different collagen fibers around here. All right, now collagen is a protein that's very, very resistant to stretch. All right, but at the same time, it is very flexible. It can withstand forces in other directions. So where these calcium salts can't really bend or have a lot of give to them, or else they just shatter, this is where the collagen fibers come in. Okay, so I mentioned in an earlier video that if I jumped up and landed on my femur, all right, or if I jumped from a higher place and landed, I should say on my feet. For example, my femur, my tibia, all right, they're going to bow a little bit. They're going to bend, all right, because I have all that energy and that force traveling downward throughout the bony structures of the lower parts of my body that are taking the brunt of this energy, the brunt of the weight. All right, if those bones didn't have any give to them, if they were just solid, compact structures, they would just compress and shatter. But with the presence of this collagen, with this flexible protein in there, the energy, you're going to have the minerals that are going to withstand the compressive force, but then they're going to be able to bow and twist because the collagen fibers can take that energy and move with it. All right, so that's that's what makes bone so tough. All right, you shouldn't be in the habit of thinking of bone as, being the same as, being a rock hard substance like this whiteboard or like a tabletop or a piece of steel, because it's not. All right, bone is a very, very flexible organ. I mean, compared to other tissues in the body, yes, bone is very, very solid compared to other tissues. But you have to remember, it is also very flexible at the same time because of the presence of collagen fibers and water as well. Now, there are also a variety